Welcome to the video lecture series on Bootcamp. The Bootcamp is actually called as a placement training. It's connected with placement training for product-based companies. Now, the first topic which we are going to discuss is called as pointers in C. Pointers in C is a very significant topic which is connected with placements. So, whenever you attend any kind of technical interviews, most of the questions will be focused on pointers as far as technical aptitude is concerned. And this pointers actually takes up the pivotal role in technical aptitude questions. Now we will step inside what is meant by pointers, because it is actually having a major role to play in C programming. Now what is meant by a pointer? So pointer is not like an ordinary variable. It is actually called as a special variable. Normally the difference between a pointer and a variable is a variable used to hold the data, but pointer used to hold an address. So pointer is also a variable which holds the address of another variable. So that's the definition of pointer. Generally it holds the address of another variable. So now we will step inside another topic. Next slide. Now I have integer a equal to 10. That means a is actually possessing a value called as 10. And the next step we have ampersand of a, and the very next step we are trying to print the value of a. Now we will learn about these pointers in a simulated fashion. So graphical representation, step by step we will just go on. Now when the first statements get executed, integer a equal to 10, what happens here is the very next step is actually memory will be allocated for a, and then address will be allocated and the value will be stored inside that. So now a will be having a value called as 10, and it will have an address location called as 2200. So this is a symbolic representation of an address. Generally address will not be in numerical form, it will be in a hexadecimal form, and the size of the address will also be very large. But for understanding purpose, to simplifying the process, we are using 2200. Okay. So this is a hypothetical address. Okay. Now when the next step comes, we will know that now what is this 2200? 2200 is called as the address of variable a. Okay. So address of a, that's actually symbolically represented as ampersand of a. Now when the next statement executes, printf ampersand u, percentage u ampersand of a. Percentage u is actually used to represent an unsigned integer. Now ampersand of a actually gives the address of a. Now address of a, what is address of a? Address of a is actually 2200 is called as an address of a. Now you can see that you will get an output called as 2200, because that is called as the address of a here. Now when we come to the third statement, we try to print a, and now we know that percentage d is used to print the values of integer value. Now what happens is a will actually print the value inside a. Okay, the value of a will be printed here. So the value of a is actually 10, and that will be getting printed inside the output. So that's about the depiction, a graphical depiction of pointers here. So we have learned about two concepts. One is called as an address of a, another is called as a value of a. Now we will step inside another concept here. I take a value called as 20, and now I use percentage d star ampersand of a. Now what happens here is, now when this a gets executed, the first statement gets executed, now a memory will be allocated, 20 will be stored inside that, and the name of the variable is a, and the address assigned to that is 3200. Okay, I take a different address now. Now when I try to print, it's called as address of a. When I try to print the next statement, percentage d ampersand of a. Now what happens here is, first whenever the statement is given like this, ampersand of a, before that if a star is there, anything like that, try to evaluate from right to left. Okay. So when we try to evaluate from right to left, you have ampersand of a. Ampersand of a is nothing but it is called as address of a. Address of a is called as 3000. 200. So that is given as 3200. Now before that star is there. Okay, star means actually value on the address. Now you got 3200 and star value on the address of 3200. It's nothing but the value called as 20. Now that will be given. Now this 20 will be given as a value to the output now. So this is how it is getting evaluated. Now we will come for the third one. The third one is star ampersand A. Okay. Now we will evaluate on the step-by-step fashion. Now evaluating from the right side. First ampersand of A. Ampersand of A gives 3200. That is address of A. Now, okay. So star ampersand, actually it gives the value called as 20. Now before that ampersand is there. That means 20 is called as a value. Ampersand of 20, the value of 20, the address of 20. Now the address of 20 is 3200. Okay. Now when you try to evaluate star, okay, value on the address of 3200 is again 20 now. Okay, that's it. Now we'll step inside the third example. When integer equal to a equal to 10. Now I take a equal to 10. It takes the address called as 2200. Now the next step is integer star of pointer. Now pointer is also a variable. Pointer will have an address now. Let us assume that address is called as 3000. Now in the third step, when I try to assign the address of A to pointer, what happens is address of A will be assigned to pointer value. So what is address of A here? It is 2200. Now that will be assigned to pointer now. Now it moves here. Now pointer will be having the value called as 2200. That's nothing but the address of A here. Now we'll go for printf %d ampersand of pointer. So ampersand of pointer is called as address of pointer. So what is address of pointer? Address of pointer is actually called as 3000. So now that's it. Okay, the next is when you use star PTR. So star PTR means you see what is the value inside PTR. Try to evaluate from left to right. It is inside PTR you have the address called as 2200. So star of 2200. That means value on the address of 2200 is actually 10. Now you will get a value called as 10 now. So that's the output. So we'll go to the next example. Now integer a equal to 10. Now I assign 10 here. Now a will take a value called as 10 and the address is 2200. Now integer star pointer, and the pointer will not take any value right now because it has only address called as 3000, because right now nothing has been assigned to the pointer. When the third instruction is getting executed, that is pointer equal to ampersand of a, so address of a is assigned to pointer. Now you know that a's address is 2200 and that will be assigned to pointer here. It has been assigned. Now we go and execute the fourth statement, printf %d star of pointer. Now whenever an expression is given like this, try to evaluate from left to right, right to left. Okay, so ampersand of pointer, the first is ampersand of pointer, ampersand of pointer. So you see ampersand of pointer, what is ampersand of address of pointer? Address of pointer is actually 3000. Now 3000, and before the star is there, so value on the address of 3000 is actually 2200. Now you can see that a graphical depiction here, 2200 is given as an output. Now we'll go to the last statement here, printf %d star pointer. So again we have to evaluate from right to left. Ampersand of pointer, ampersand of pointer is nothing but the address of pointer value. So address of pointer is 3000. We can see here address of 3000. Now star of 3000. So first evaluate the first star. So star of 3000 means value on the address of 3000. So value on the address of 3000 is 2200. Okay. Now the next is once again evaluate the last star here, dereferencing operator. So star of 2200, star of 2200 is nothing but the value on 2200 is 10. Now that is getting transferred as an output here. Now what is the role of this indirection operator? So this indirection operator is also called as a dereferencing operator. When you use star inside a pointer, then that is called as an indirection operator or dereferencing operator. But the constraint here is star cannot be applied on numbers. It can be only applied on address. Okay. Now we will take an example which actually proves that this rule is right. Now integer a equal to 30. Now I take a value as 30 here and it takes an address 2200. Now we will try to print the value of ampersand star a. So when I try to print ampersand star a, now try to evaluate from right to left. Ampersand a. Now what is inside a? A is having 30. Now star of 30. Now 30 is not called as an address. Star, when I apply a star on a value, then obviously that is not right here. It actually violates the rule of C programming. So it results in an error message. So you can see here 30 is actually a value, star is applied on a value, so it results in an error message. So that's about the use of indirection operator. Now we will take another example to reinforce our knowledge in pointers. Integer a equal to 10. So now I have a graphical illustration of a here. So a's address is actually 1000. It takes a value called as 10. Now I take the second value, second instruction, star pointer equal to ampersand of a. Now here the declaration and the initialization has been done in one single line. Now here ampersand of a means address of a, that is assigned to pointer 1, and pointer 1 itself has an address called as 2000. Now we will take the third value, third instruction, integer star star pointer equal to ampersand of pointer 1. So I am using a double referencing operator here, double dereferencing operator or double pointer. Now this is called as pointer 2. Pointer 2 has the address of pointer 1, isn't it? And then pointer 2 address is 3000. Okay. Now this is the graphical illustration of the memories allocated to three respective variables here. Now when we execute the fourth statement, the fourth statement is percentage d star of pointer 1. Okay. Now you try to evaluate star of pointer 1. So now see what is inside pointer 1. Pointer 1 is having a value called as 1000. So star of 1000. So value on the address of 1000, value on the address of 1000 is actually 10. So that's the output. Now we try to execute the fifth statement here. So star ampersand ptr1. So star ampersand ptr1. So when you try to execute ptr1, you see here what is inside ptr1. ptr1 inside ptr1 it is so ampersand of ptr1. Try to execute ampersand of ptr1. Ampersand of ptr1 is address of ptr1. Address of ptr1 is 2000, isn't it? Okay, star of 2000. The value on the address of 2000 is again 10. Okay, value address of the 2000 is actually 1000 here because 1000 is actually the value given to ptr1. Okay, now the last one. The last instruction is percentage d star of ptr2. Okay, now we will see star of ptr2 here and see what is inside ptr2. ptr2 is having a value called as 2000. So star of 2000, that means the value on the address of 2000. Value on the address of 2000 is 1000. Okay, so that is given as an output. Okay. Now we will take up another example. So the respective same address which I have used in the previous slide has been used here. Now I execute the fourth statement. So star of ampersand of PTR2. So you know that evaluate from right to left. So ampersand of PTR2. So what is ampersand of PTR2? It is address of PTR2. So address of PTR2 is actually 3000. So star of 3000, value on the address of 3000, you know that 3000 consists of 2000 as a value here. So now that is assigned as an output here. Now we'll go to the last statement, fifth statement, star star PTR2. Now you see what is inside PTR2. PTR2 has a value called as 2000. So star star 2000. So evaluate the first star. When you evaluate the first star from the right. So star of 2000, value on the address of 2000 is 1000. Okay. Now one more star has to be get evaluated. So star of 2000 here. Star of 1000. The value on the address of 1000 is actually 30. Now that is given as an output here. So this is called as a second output. Now we'll go with the MCQs now. Find the output of the following. Integer x is equal to 100 and ampersand of x. I try to print the value of ampersand of x, and the next is ampersand of star x. Okay, now what is the output? I have given three outputs here, but when you use ampersand of x, obviously it is called as address of x, isn't it? So address of x, and when I use star of x, so x does not have an address now. X is having a value called as 100. So star cannot be applied on 100 here. So obviously the answer B is the right answer, address of x and error. Now we will take this example. So integer x is equal to 100, then int star PTR is equal to ampersand of x. Now when I print PTR, okay, PTR actually contains the address of x here. So the first answer is address of x and star of PTR. So address of x, PTR has an address. So star of PTR, value on the address is actually 100. So again, the answer is the first one, address of x and 100. The third one, find the output. You have, I am using a double A pointer here. So last statement, I try to print PTR2 and PTR1. So what PTR2 consists of? PTR2 consists of the address of PTR1, and PTR1 consists of the address of x. Okay, so address of PTR1 and address of x. Answer B is the right answer. Now integer x is equal to 100. So I assign the address of x to PTR. Now star of PTR and star ampersand of PTR. So when I print PTR, star of PTR, PTR contains the address of x here. So value on the address, then you will get a value called as 100. And the next one, star of ampersand PTR. So ampersand of PTR, address of PTR. Address of PTR is actually, you have a hexadecimal address now. Star when you applied on that. Okay. Now it's nothing but it will give the address of x. So the answer is A, 100 and address of x. So thanks for watching the video. Have a good day.